G'day. Today I'm making a video on MS3 boost control. I'm going to run through just what I'm using for the test setup first, then we'll run through some open loop quickly, and then go into sort of the closed loop, the three different modes of closed loop, strategies that you can use to make it work well, and then we'll do some bench testing and you can see the cause and effect of changing things like PIDs and some of the other parameters in there. So here's our setup. We're using a MS3X ECU, pretty much the same as most MS3 products if it's got the same firmware. I'm running 1.5.2 RC13, which is the latest at the moment. It's a release candidate, not a released version, so it's what comes after a beta. We're running off a couple of different batteries because that's what I've scrounged up in my hotel room in quarantine here. We're making the whole shabam work with the RPM and TPS through this. It's a engine stimulator I built myself. Basically uses the RG-Stim software, and then all I need really for this testing is I've got some pots that control engine speed, and one that does TPS, so that'll get us through the tables there. I'm running the new Speeduino fork of software, which is pretty slick. So yeah, it's got a few things in it there that are worth looking at. Bunch of different wheels you can choose, and a good little firmware loading interface. Pretty sweet little tool. And the last piece of the puzzle is my turbo. It's an 80mm. I'm going to go billet next year, but you know, this is what I've got for now, so it's pretty sick. Right, alright, let's get into it. Alright, we'll start off with open loop. So come down in your algorithm, select open loop. All this crap down here is for closed loop, that'll grey out. And also your boost control lower limit delta kPa will grey out as well, because that's not used in this setting. We'll have a look at that when we get into the next mode. Alright, so basically we've got one table and it does what you tell it to do. So I can move around the RPM here, and you'll just see that it blindly follows what is going there. It's interpolating between those cells. You'll see if I get between the 50 and the 100. Now the noise you'll see there is just RPM jumping around because my stim's using a pot to read the RPM. That would be more stable if we could use the sweep mode or something like that. And then also up and down on the throttle position sensor. So there you can just see it's following that table, dead simple. So you can start off in this mode if you want. It's a good mode to set up things like your minimum duty. So your minimum duty here. So get that table running in open loop, or setup mode, which we'll go into next. Set that to all, say 15, or actually set it to all 0, run your car and see what boost it makes. That's what it'll make off the actuator, and then jump it up to say 15. If it makes anything above that, then you know that 15% is enough to raise your boost. Now all that is dependent on what solenoid you're using, the frequency and a few other little factors. But let's say for a Mac valve of 9.5 Hertz, I've found around the 20% mark, maybe something like that. It'll start making boost above your actuator pressure. A good way to set it up is just do a couple of runs, set it to all 20s, set it to all say 35, all 45, depending on how much boost you want to run and what your setup's going to do. And then you can just go back and look at your data logs, look at the RPM, at what boost it's making, and you can sort of work out what it should be, and then you can come fill in your table, run it again, and then just test and adjust from there. That's basically how I do it. So that's in a nutshell open loop. I'm not going to go too much into that because it's pretty simple really. Alright, so now into the meat of the topic. Let's go boost control settings, and we've got closed loop now. You've only got open and closed loops, the only options there, and in the tuning mode we are running setup mode. So there's basic mode and advanced mode. We'll touch on those in a minute. So setup mode is primarily designed to set up your table. And when I say your table, we've got two tables. We've got our target table and we've got our bias duty table. And this is the one I was talking about. So setting this up, this is what you want to run. It's your target, because now we're running closed loop. And this is the duty it's going to need to make that target at that RPM. And you can see we're down here with the throttle position. We'll just turn it up for the sake of it. Actually, we can change these values here, and let's say 180, and then you'll see, have a look over on the right at the boost, the bias table, and you'll see it move up there. So that's the cells that's going to be reading from. So your control target table is where you set up what you want to run, and that's based on throttle position. So just like your other closed loop, open loop setup, it can be based on throttle position, but now we've got two tables to do that with, to do our setup with. Alright, so I'll set all those to 150s and we'll ignore this for now, because we want to talk about our bias duty. Alright, so we're reading from the 150 line like we just set it up. You can change all these, by the way. That's all easy to change. Alright, so basically what it's doing in this mode is it's reading off this table, but you see now that's saying 52, we're reading 80 up here on our boost duty, right? So that's because this lower limit delta kPa now is in effect. So if we put some boost into it, turn our boost up, yeah, we'll move that table across so we can see what we're doing. Alright, so now it'll jump to the value on that table. Now we're getting a fair bit of noise on that, again due to our the pot setup here, but I've got some 50s over here. Yeah. So now the values should all be 50 when it jumps up, and you'll see now it'll be stable. Look at that, dead stable. Alright, so what we'll do in this mode is when you'll enter the setup mode when you get within the delta. So when I say that, I mean this value below what is your current target, so where you are on the target table that we showed there, so that one. So it's at 150 now, 15 below that is where we're going to go from the maximum duty number, so whatever we put in here. So I've got 80, if I change that there to 90, you'll see it jump up there. And you'll see when it goes into the PID, it'll be constrained between these two values. It won't go above or below, unlike in open loop mode. It would just do what the table said. In this mode, it'll constrain it to these values. So let's just test that and see. If I go to 100 here, it's not changing. Yep. Right, maximum G, put that back to 80, and then you'll see, yep. So it's constrained between those two values, the upper and the lower limit there. Alright, so when we get within that delta limit, it jumps up to straight whatever's on the table. Now this is what it will do in all the closed loop modes, and that's why this is the bias table, because it sets up what you want it to do. So we're putting a bit of not intelligence, but a bit of pre-known knowledge, so stuff we've worked out either by setting it up in this mode, or if you run previously ran in open loop, then you should be able to have a look and at that table and transcribe over to this table to see what it should be running, and you should be able to fill in that table. So we'll just have a bit of a play around here. So we've got to get it up and then we've got to change the RPM. And it'll follow those values. There we go. You just see it'll blindly go up and down there, but it also has that jump where it jumps up to your maximum. So I actually like this as an open loop probably better than open loop mode, and don't be afraid to do that. It probably does have a few advantages using it in this mode rather than using the normal open loop mode. Very similar, but I would say this is probably a touch better. Alright, let's roll on into the next mode. So now we've got basic mode selected. Now we've got a sensitivity bar here. So this goes from 0 to 500. 0 doesn't necessarily mean it's doing nothing, but it is very low. 500 is a crazy setting and no one should use it. Your PID will be blanked out in basic mode, but basically what it's doing in basic mode, it sets them all to 100 in the software. So I think from what I understand, advanced mode with all hundreds in here and basic mode is going to react exactly the same. Our lower limit delta kPa, it becomes a very important mode now that we're in true closed loop, because setup mode is really open loop, but you're just setting up for closed loop. So now that we're actually in a proper closed loop, we'll see the PID doing its work, and this becomes very important. So I'm just going to show you something now to explain exactly what I'm talking about. So I've changed this to 40 now, so that's pretty loose. I'm running 150 kPa, pretty much limited because I'm using a syringe to pressurize. But let's have a look. I'll bring up the bias table. We can chuck you down here. Let's change our RPM. So we're not dealing with that noise. It just makes it easier to see what's going on. Alright, so let's pressurize and see what happens when we approach our boost limit. So turbo comes on to boost, and have a look at the boost G there. So it starts at our 50 value and it actually shoots up really quickly. So I'll just do that a couple of times. So if you've set it in setup mode to run the boost that you want to, so it should be running 150 at that 50% duty. As it's coming on boost, the PID is just chucking in an extra 15 on top of that just to ruin your day. And what's that going to cause? It's going to cause an overboost. So see it come on the boost there, and you'll see it jump up every time, and that's going to ruin your day. That's going to give you this overboost, and then it'll track back down as it comes back down. So what we need to do is this value here, little talked about but very important in closed loop mode. So we're going to change that to 15. Make that as tight as you can. So do a bit of testing. If you can get it to 10 without overboosting, then that's even better. But I'd start at about 20 and then work down from there, and see how responsive. You'll be surprised. A turbo coming on boost can be slowed down quite quickly, and yeah, keep that as tight as possible. Let's have a look now how that affects it, and we'll come on boost and have a look at that there. So the reason why, if you think about it, if you're telling the PID to start doing its work when the delta is 40, that's a massive error signal. So that's going to drive a big change quickly. Whereas when it only starts to make a difference when it's 15 IA, the error signal is nowhere near as big, and it's not going to shoot up at that massive rate. It's a little bit of an error, and it'll it'll change a little bit, but you can see there, like, even coming up boost slowly, it's going to hit pretty close to your target. And if you can't get away with it, then maybe you can just pull 5%, 3% maybe out of your bias duty table, so by the time it is raised up a touch, it's hitting where you need it to hit. So there you go, that's a hot tip there. So let's just have a look at the PID doing its work anyway. So we'll come up, we'll give it a bit of an error signal, and you watch it drive there. So yep, that's doing its thing. The spike there was I went below that 15 delta limit, so it'll spike back up to 100. That'll bring you back on boost faster. There's no such thing for that, but there we've hit our lower limit, which is I think set to 18 or something like that. Now there's a few things going on here. So it'll jump into the PID loop at the value in your bias table. Then the offsetters of the bias table, as you move around that table, will offset where it's at. It won't necessarily run the same value as in the table, because any changes the PID has made will move it around. But I'll try and show you. I'll hit on, this is more difficult than it sounds. I'll try and get the error signal to nil. Alright, our PID is pretty much not doing much. And then we move around and you can see that the bias table is still affecting what it's doing, but it will be offset. So I'm sitting at 50 now. If I bring it up a bit, I should be offset by that amount that I brought it up there when I do this. And you can see it didn't go quite so low there. And then it resets every time you come down below that delta. That's another reason why you want that delta tight. If you drop it, boost down, like you get off the throttle momentarily, you can pop straight up and it will reset that value. So if the PIDs run away from you, it'll reset that and bring it back to where it should be if you've got that bias table set up properly, right? Okay, let's have a look now. I'll just show you what happens if you do something stupid. So 500, and this will just create a square wave. So this is so sensitive. You can see the error signal just is multiplied. So that sensitivity is basically a multiplier. It just makes the whole thing more sensitive, obviously. And then we'll try another setting at 0. So that's no error signal. We'll feed an error signal in, and you can see it's still doing something, right? It's not very quick to respond, but it is still making changes. Now this is pretty cool, because if you want basically open loop with a tiny bit of correction, then you can just set that sensitivity low, extremely low like that, and what will happen is you'll still have the bias table doing its work, which is working like an open loop setup, as shown there, but then it's just adding a bit of correction. So it might be correction for pressure of the day, just to bring it back that pound or two of boost that you might be missing. But then again, if everything else is set up, you should be able to get away with a bit more than 0. I think around the 200 mark usually works okay. What will happen if you have the sensitivity too high is the changes will be made, and then it will be still applying corrections without those changes affecting it. So you know, there's a lot of steps in the process between you changing your boost duty and that affecting the speed of the turbo and then the airflow into the motor, etc. So you need to wait for the change you've made to have an effect on the other side before you need to keep making more changes. So if sensitivity is too high, that's what's going to happen, and what you'll see is oscillations basically. I can try and show you basically what will happen, but your boost will oscillate like this around your target, and that's what you'll get. And your PID might go crazy. You'll see that. You'll see an oscillation in your boost. You'll see an oscillation in your boost duty if you're too high. And maybe it'll come good. Like it'll start off with a big oscillation, and then it'll come good. But definitely to hit your target originally, make sure that your value down here, the lower limit, is as tight as you can get away with. So yeah, maybe 20 and go lower, see how you go. But that's a big one. Alright, now let's go on to the final topic. So now we'll turn it onto advanced mode. We've still got the slider, and now these are in effect, so you can change the values. As I said before, if they're all hundreds, I think it's the same as basic mode. That's my understanding. But basically what we'll do now is I'll sort of play around with these values, and I'll show you what each one does sort of by itself. So we need to go to 1 and 1, and let's say 200. Alright, so we've got our sensitivity. Let's try around the 250, so about halfway on the sensitivity. And we've got maximum, so these maximum value is 200, minimum value is 1 for all these fields here in your PID. We'll burn that and go to our boost control page. Right, so this is, and you can see the PID values are here, and the sensitivity is there. Target's there if you want to see where we're at while you're watching the video. Right, what does proportional do? As you can see, we can feed in a massive error signal, and all it's done is this little bit here. That's what the proportional's done. And here's something funny, if you lower it, it'll raise, so we can create a sawtooth even though we're sitting above our target. So we're above our target KPA the whole time, and we're just making a sawtooth with a sawtooth. As it goes up, it goes down. So that's our proportional. You can see it's just reacting to those immediate changes, but if we sit steady, which is kind of hard to do, it doesn't actually do anything. Those steps you'll see there, that's the integral. They're tiny little integral steps, because we haven't got it set to 0, we've got it set to 1, and we've got the sensitivity bar to set to midway. Alright, so that's proportional by itself. And I'll just reinforce the fact that it's this sensitivity bar and this is all added up, all these three values are added up together, so it's quite complicated when trying to compare settings. If there's two things changed, it's kind of difficult to compare them. But I guess the point I want to make is the integral is really, the integral is the one that's doing the work most of the time, and it's the one pulling you back to where you need to be. So we'll send that one back to where it came from, back to 1, and now we're running 200 integral, and this is where most of what you see the PID loop doing comes from. And it's set to 200, so she's really sensitive. And if it's above, it'll go down. If it's below our target, it'll go up. It seems to stick to pretty much the same rate, depending on error signal. So the higher the error signal, or the further you are away from your target, the greater the rate. But the rate doesn't seem to change over time. I'll just do like we've got a small error signal there. Yeah, it's kind of hard to maintain, but I'm sitting on 149.7 kPa, holding it pretty steady, which is kind of hard to do. And you just see the integral just doing its little thing there. So that's integral, and that is the most aggressive. I guess it never goes away. If there's an error signal, it's always on the job doing something. So that's the one you probably see doing the work most of the time. Alright, we'll get rid of that. Back to 1, and we'll turn our derivative up to 200. Now this is kind of derivative. Once again, the derivative won't do anything with an error signal. It is just going to sit there. I think what you're looking at there, those tiny little moves there, I'm not sure. That must be derivative. I'm not sure that could be. It looks like it's doing the same as proportional, but I think the derivative is maybe dampening the signal, dampening the movement of the boost duty. I originally thought maybe it reacted to those spikes, like it would lower the duty if your boost spiked up quickly like that, but as you can see, it's not really doing that. And when you start adding in the other two, it's really sort of difficult to figure out what the derivative is actually doing. I'll try explain that. So we'll put in 50 integral, and let's say we'll shoot for, let's get it up a bit. So we'll shoot for this 163 line here. And we've got about, yep, that's the rate. And we'll have a bit of a play around. It's doing that. Alright. Now we'll get rid of that derivative. Oh, sorry, we'll put the derivative in. Now let's try and drive it up a bit. Maybe it's going slower. I don't know. So we'll shoot for that 163 again. And that's, I'm a touch lower, I'm about 2 kPa lower. So maybe it's a similar sort of reaction though. And if we do a sawtooth, maybe there's less noise on the boost duty. I don't know, but these are small changes that we've made a drastic change to the derivative, and I can't see a huge change in the output. So I can't really make a definitive assumption on what that's doing, really. Changing it 10 or 15 I don't think is really going to make a big impact. So yeah, I guess we'll set in some maybe 15, 20 and 5, like or maybe an 80. And we've got midway sensitivity, so this is a setup that someone might run. I don't know. And we'll just see what it does. Really, that's nowhere near. That's heavily over boosting. That's not really reacting as much as you want it to, but I mean, if you've got your bias table set up, then really what it should do is shoot up pretty much to your level there. And you can see it's not really reacting to those changes, so you probably want to have a bit more or something in there. We could turn up the sensitivity, or we could just turn up those numbers as well, which would sort of do the same thing. Right now we're just having a play now. That spike you saw there was me going below the threshold. It's really not that sensitive. I think it needs a bit more integral. Let's go 50. There we go. And that's going to be much better. Alright, so yeah. So we're sitting on our target pretty much, and it's not really moving. Doing tiny little adjustments. You change gears and bam, she overboosts a touch, yeah, and that'll just give you enough of a spike to bring it down. Maybe in a higher RPM, your boost might start to fall, and then we'll see it track up. So those things there would probably work quite well if everything else is set up. But you might turn this down and then say maybe raise this up to 150 and say 85 maybe, and we'll see if we get the same kind of reactions. No, that's nowhere near as responsive. So that's probably not doing much. It's really the integral, I think, that we're seeing do most of the work there. But let's go for 110. See what that does for us. There you go. Probably want it a bit more reactive than that. We've got a little bit of an overboost and it's not really doing much, but I guess it's not really that much of a deviation really. 150 to, what was that, like 155. It's not much of an error signal. Like you might be happy with that. But if everything else is squared away, as long as you don't go too sensitive to cause that oscillation, then you should be fine. You can go as sensitive as you can get until it starts oscillating, and that's where the control system is unstable. That's all I'm going to touch on for today. I'm not really sure. I mean, you can only bench test so much. It's really just to show you how it all works, and changing those settings, how they affect everything. But obviously testing on the car is a whole different ball game. It's a lot harder when you're out on the road and you know, hitting crazy speeds, etc., or at the drag strip, trying to make changes in between passes. But this should give you a bit of a foundation on what changes are going to affect it, and how to sort of set yourself up for success from the beginning, so you don't end up with any crazy overboosts, which can be quite frustrating when you're trying to set up your boost control. Alright, thanks for watching. Don't bother subscribing. Have a good day.